We're at gotomath.com. Click on the calculus. Go down to volume, the disk method, and we're doing 4.1. Yes. 4.1. Find the volume of the solid formed by revolving about y equals 3. What? What the heck does that mean? Well, instead of revolving about the x-axis, we're revolving for some reason about y equals 3. And the reason is just in case you see something like this, right? So if you can imagine, really, if you moved the whole problem down, moved it down to where the y equals 3 is now y equals 0, right? And revolve the same shaded region. Now, of course, you're moving the function down 3 units also. Okay, so where this right here would be right here. We'd end up finding the same volume. Okay, we'd end up finding the same volume. So what we're going to be doing here is just taking this number here and subtracting it from this piece here, right? Taking the top, subtracting this to get, it's just basically the same thing as moving everything down, all right? Moving it down, okay? And obviously we're going to be using the disk method, right? So we're not revolving this shaded region around the x-axis, we're revolving it around the y-axis, which is y is equal to 3, I should say. Actually, scratch all that. I didn't even mention to say the y-axis. We're not going this direction. I do have some problems for that. No, we're going in this direction here, right? I didn't mean to say y-axis. Okay. Did we write that down? I don't think I did. Let me write this down. So f of x is equal to x plus 3, y equals 3, and we're on the interval between 0 and 15. All right. And that should be 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I do that, just make sure. Make sure of something. Okay. So the way to deal with this is well, I guess first thing I'll do is just write down what they gave us there. So they give us, what do they give us? X plus 3. Yeah. All right, that's our radius that's changing. And then we're revolving it around y equals 3. And we're on the interval between 0 and 15. 0 and 15. Okay. All right, we got that. So let's set it up. We're going between 0, 15, pi, remember? And it's going to be f of x minus, right, it's going to be the top line minus the bottom line. And that gives us the difference. Okay, that's all that's doing, is giving us this, that's the radius right there. All right. So we have x plus 3 minus 3, and the whole thing is squared. The whole thing is squared dx. So that's all we got to do. That's it. Let's simplify this thing down. 0 to 15. And going, let's see, this is x squared dx. And we can now take the integral. You know what? Let's just do it right here. So pi x cubed over 3, going from 0 to 15. All right. So we go ahead and plug our stuff in. So we got pi times 15 cubed over 3 minus 0. Minus 0. I don't think we're, what are we doing? Oh, don't say anything about rounds. So we want to get the exact value, right? And we can do that. All right, we can do that. So everybody should know what 15 cubed is in their head. If you don't, I'm going to tell you it's 3375. But then we want to divide by 3, and obviously 3 doesn't, oh, 3 does divide into that, doesn't it? Yeah, I should have known better. 3 goes into 15. Anyway, so we ended up with, after the smoke cleared, 1125 pi. 1125 pi. Okay, finish out the graph there. All right, now something else we should mention. Let's say this is units, and this is just general for centimeters, millimeters. No, not millimeters. Yeah, we can say millimeters, meters, cubed. But we don't write this in here. But remember, this is volume that we're calculating, right? But we're leaving this part off. Okay, let's go up here. Let's hit the answer. 1125 pi. All right. I just looked at my calculator and I saw 1125. I'm like, where's the pi at? That was really weird. That was kind of bizarre. I looked at my calculator like that's what we're supposed to be. Never mind, forget it. We're over here at gotomath.com. Check it out.